picking up with example F, if we start with ammonium nitrate decomposing into dinitrogen monoxide and water, my first step is to do what? Draw the lines, make your column over the arrow to separate your reactants from your products. So in this case, I only have one reactant. This is what we call a decomposition reaction, where you have only one thing that's going to break down into multiple things. And then even though NH4, ammonium, is a polyatomic ion, and NO3, nitrate, is also a polyatomic ion, I don't have NH4 and NO3 on this side of the equation, so when I list them, I'm not going to list them as just your polyatomics. I'm going to list the single elements on their own. So if I have nitrogen, I'll list that first. The next element that I run into is hydrogen, and then after that I run into nitrogen again, but that'll be counted here, and then I run into oxygen. So I have nitrogen, hydrogen, and oxygen. And then on my product side, just to double check that I didn't skip anything, I have a nitrogen, oxygen, hydrogen, oxygen. So everything is accounted for, and then I just go through and count everything up, remembering that even if you have an element in two separate places on one side of the equation, they get added together. So on my reactant side, how many total nitrogen atoms do I have? 1, 2. On my reactant side again, I have 4 hydrogen atoms. And on my reactant side, how many total oxygen atoms? 3. On my product side, I have a total of 2 nitrogens. How many hydrogen atoms on my product side? 2. And I have 2 oxygen atoms on my product side. So far, so good? Okay, so all we have here is a tally, a count of how many atoms of each type are on each side of the equation. My nitrogens are what we call balanced because I have 2 on one side and 2 on the other side. If I go down to hydrogen, I have 4 on my reactant side but only 2 on my product side, so I need to use a coefficient somewhere on my product side to change the count of hydrogens. So I can't just change the number down here without using a coefficient somewhere. So in this case, I'm going to find the compound that contains hydrogen on the product side, so that would be this one. And what coefficient would help me here? 2. So coefficient of 2 in front of H2O, 2 times the 2 hydrogens that I already had gives me a total of 4 hydrogens. And then 2 times the 1 oxygen here is how many total oxygens from water? This water will give me how many oxygen atoms? 2. Plus, I add to that the 1 oxygen atom that I already had from N2O. I didn't change this one at all, so I just keep that 1. So now, instead of 2 total oxygens on my product side, I have 1 plus 2 oxygens, so that would be 3. And then this one is balanced at that. My nitrogens are equal, my hydrogens are equal, my oxygens are equal. So in the rest of my blanks that I didn't have to change, what do I put? 1s. So if you were to recognize this on a multiple choice test, the stream of numbers would be 1, 1, 2. Good? Alright, in this next example, what is my first step to balancing? Make your column to separate the reactants from the products. So we find our arrow, I draw a line straight down and straight down. Then my next step is to list all of the elements, or all of the polyatomics if you have them, in that column to count them separately on my reactants and product side. So the first element I run into is carbon, then I run into hydrogen, and then I run into oxygen. How many total carbons are on my reactant side? Good. How many total hydrogens on my reactant side? And how many total oxygens on my reactant side? On my product side now, how many total carbons are there? How many total hydrogens? And how many total oxygens? So I have 2 plus the 1 gives me 3. Keep in mind you have to keep looking for oxygen in multiple places to recount them every time. So I have 6 carbons on one side of my equation and only 1 carbon on the other side, so I want to use a coefficient on my product side somewhere to get this tally to change to a 6. So what coefficient would help me and where? Okay, a coefficient in front of CO2. What coefficient? 6. So a coefficient of 6 in front of CO2, 6 times 1 carbon gives me a total of 6 carbons. 6 times 2 oxygens gives me 12 oxygens from CO2, plus I still have the 1 oxygen from H2O. So 12 plus 1 changes this count to how many oxygens? 13. So I'm going to explain that one again so that you guys don't get lost here. This is why it is important to do all of your math, all of your multiplying, all of your distributing only in the actual reaction itself where the coefficients are, and not down here, because I used a coefficient of 6. 6 times the 1 carbon, change that to 12 carbons. Yeah. And then 6 times the 2 oxygens, 6 times 1 carbon, change it to 6 oxygens. I keep messing up my words. Let me try again. 6 times 1 carbon, change that to 6 carbons, and then 6 times 2 oxygens gave me 12 oxygens from carbon dioxide. Since I only put a coefficient in front of carbon dioxide, that's the only one that got multiplied out. And then I add to that the 1 oxygen that was already a part of H2O. So then the 1 plus 12 is where I got my 13. If you multiplied your 6 times the original 3, that gives you a different number. So you can't do your math down here. That's why we took the note that you use the RNP count just as a count, or RNP charts to count or tally all of the atoms. So this only changes as a result of what you're doing in your coefficients. So now my carbons are balanced, my hydrogens are not balanced. I have 6 hydrogens on my reactant side, I want to get 6 on my product side. So what coefficient will help me and where? 2 on H2O. A 2 on H2O, 3 on H2O. 3 times 2 hydrogens, we'll change that to 6 hydrogens. And then 3 times the 1 oxygen from water changes this number to 3, so I'm going to make that a 3 now. But I still need to add that 3 to the original 12 that I had from the 6 CO2. So 12 oxygens plus my 3 oxygens now from H2O, or 3 H2Os. So 12 plus 3 is 15. So now I have 15 oxygen atoms on my product side. My carbons are balanced, my hydrogens are balanced, and my oxygens are not balanced. So here is another one of the tricks that sometimes confuses students or sometimes makes it way easier for them. If you notice that you have oxygen, O2, on one side of your equation, but you have an odd number of oxygens on your other side of the equation, there is nothing that I can put here, no whole number, that would make this equal that. This is going to have to end up being an even number of oxygens somehow in order to equal this, since this will always yield an even number of oxygens. Do you see that? So, 2 ways you can approach this. One are start plugging in numbers over here to get a total even number of oxygen atoms. Or, what I like to do is temporarily use a decimal point to get your numbers perfect and then get rid of your decimal at the end. So, what I mean by that is there a coefficient, or what coefficient, because there is one, could I put here to get these numbers to equal each other if the coefficient did not have to be a whole number? 7.5. So, 7.5 is half of 15, so when I multiply 7.5 times 2, that gives me 15 oxygen atoms. So we are not allowed to keep our coefficients as anything with a decimal. It has to be a whole number every time, but we can temporarily use this to make the balancing a little bit easier. So if this trick doesn't work for you, if you don't like it, if you couldn't see that part, that's okay. You can always just keep changing this until you get an even number on this side and work backwards. But I tend to prefer this way. So if I have 6 and 6, 6 and 6, and then 15 and 15, we're all the way balanced. So then what number would go here? 1. So you put that 1 there. Keeping in mind that this is all temporary because I cannot balance my equation with a decimal. So the way that I'm going to get rid of this decimal right here is by multiplying my entire equation by 2. and then I'll just change every single one of my coefficients to be double what it currently is. So instead of a 1, I now am going to make this a 2. Instead of 7.5, I'm going to make this a 15. I'm going to circle them just so they stand out. Instead of a 6, I'm going to make this 12. And instead of a 3, I'm going to make this 6. So when you double that, you get rid of your decimal point, you get rid of the 0.5. And then to double check and make sure that you actually still counted everything effectively and you didn't mess up your balancing in doing that, go through and recount all of your atoms. So 2 times my 6 carbons gives me a total of 12 carbons on my reactant side. 2 times 6 hydrogens gives me a total of 12 hydrogens on my reactant side. 15 times 2 oxygens gives me a total of 30 oxygens on my reactant side. 12 times 1 carbon gives me a total of 12 carbons on my product side. 12 times 2 oxygens gives me a total of 24 oxygens from CO2 plus 6 times the 1 oxygen gives me another 6 from H2O. 24 plus 6 gives me how many total oxygens? 30 on my product side. And then finally hydrogen, I have 6 times the 2 hydrogens gives me 12. So this is balanced, and I didn't have to go back and forth and guess a whole bunch of different numbers, mess up my balancing, all of that. So if you end up in this case, it is always with O2, or usually you'll see it with O2. Sometimes it could be another diatomic element. Using the little 0.5 trick is sometimes helpful, but if you get lost in all of that, that's okay. You can still balance it other ways and come up with the same result. If you use this trick, make sure that at the end, your numbers get pretty big. So I have a 2, 15, 12, and 6. Those are the coefficients, 2, 15, 12, 6, that you would have to recognize. They are already in the lowest common ratio here. There's nothing that I could reduce all of these by. Sometimes you'll use this trick and then you'll notice that you're actually able to reduce them by something. So if that happens to you, just make sure that you reduce it before submitting your final answer.